Welcome to homework.
So in this problem, we have a kind of a structure here that consists of two bars, and so we have a frame or structure that consists of two bars. They're pinned at their left ends, and then they're pinned together. Here, this bar makes a right angle here, and so they ask us to take a look at the internal force of moment here and here, kind of midway along the horizontal sections of each bar. So to find these reaction forces, we can just sum forces and moments on these two pieces. On this piece, we have F1x plus F2x equals 0, F1y plus F2y equals 0. And then take moments about this point, we find that F4 times F2y equals 0. So we know that F2y is 0. For this part, we have F3x minus F2x, F3y minus F2y, and then we have a point load, external load acting at this point here. So that's minus F naught. And then taking moments about this point, we have minus 4, this distance here, 4 meters times F naught. Then we have a point moment here, so we need to take that into consideration. So that's in the negative direction, so minus m naught. This distance here is 1.5 meters, so the moment arm generated by the x component of the force at F2 is 1.5 F2x, and then the y component, this is 4 meters, so we have minus 4 F2y. These 6 equations have 6 unknowns. Fortunately, a lot of them are pretty trivial to determine. We find that F1x is minus 2.2 kilonewtons. F1y turns out to be 0. And because we know that F2y is 0, so their sum has to be 0. F2x is 2.2 kilonewtons. Again, F2y is 0. F3x is 2.2 kilonewtons, and F3y is 600 kilonewtons, or 600 newtons. So basically, this point here carries this entire load because this component is 0, because this one is 0. So we can then start taking cuts, and fortunately it's easy with these cuts because we can just look at this section and this section, and since we know what these are, it's easy to determine what these are. So here we have N1 plus F1x is 0, and then we have V1 plus F1y is 0, and we have, this is 2 feet or 2 meters in, so we have 2V1 plus M1 equals 0. Down here we have N2 plus F3x equals 0. V2 plus F2y is 0. And again, this is 2 meters, so we have 2V2 plus M2 equals 0. And so we can solve these three, solve these three for N1, V1, M1, and then solve these three for N2, V2, and M2. And doing so, we find that V1 and M1 are both 0, as we'd expect, because there's basically this is carrying no moment. And then N1 is 2.2 kilonewtons. V2 is minus 600 newtons. N2 is minus 2.2 kilonewtons, and M2 is 1.2 kilonewton meters.